Hello everyone, welcome back to my channel. My name is Piyush and this is video number 21 in the series CK 2024. And in the previous video, we have seen the basics of SSL TLS and how actually it works. How do we secure our connections from client to servers and so on. We have looked at in detail. And in this video, we'll be looking into TLS specifically for Kubernetes. Like how does it work in Kubernetes and how do we actually create the certificates? How do we create certificate signing request and the overall process of it, which will be very helpful while working with Kubernetes. So the comments and like targets for this video will be 220 comments and 220 likes in the next 24 hours. I'm sure you can do that. So yeah, thank you so much for your support so far. Let's start with this video. So in the previous video, we have seen like we create certificates for server, and then certificate authority also creates certificates to sign the request. So let's look at the quick recap of only that part. I'm not going to cover everything. So just that part. So client creates their own certificates to authenticate with the server, right? Because server sometimes asks the client identification, like who are you actually? Can you identify yourself? So in that case, when the server asks for that authorization, so client reply with the certificate and the details to show that yes, who I am saying I am. Okay. And in the same case, server also generates their own certificates and the private key. These certificates will be helpful in ensuring that there is a secure communication between client and server. And with the help of this, actually the communication will then be made, right? So like this. So this is like the get request and response. It is handled with the help of certificate. Now we have a certificate authority in between. So this certificate authority is responsible for issuing the certificate. So server actually request the certificate to the certificate signing authority. And this could be like any certificate authority such as Symantec, DigiCert, or anything else. So we can use one or more than one certificate signing authorities. So over here, server requests the certificate uh, to be signed by a certificate signing authority, and in reply, certificate signing authority does the validation of the server. It checks the authenticity of the server and checks if the server owns the domain or not. And based on that, it actually issues the certificate. Okay. And the request will be made by issuing a CSR, a certificate signing request from server to the certificate authority. Now, how does certificate authority actually issues the certificate and sign the certificate? It does that with the help of its own pair of public certificate and private key. Right? So certificate signing authority has its own pair of certificate and private key. Right? So using that, it will sign the certificate and issue the certificate. And this public certificate is also installed in the client's browser so that it will do the validation that certificate is valid or not, and it is actually not expired. It is issued by a valid authority and so on. So it does all the validation for you. So this is the overall process. So we see we have three types of certificates. First is client certificates, which is generated by the client. So these are called client certificates. Then we have the certificates that is generated by certificate authority. So we call it root certificates. And then we have the certificates at the server. So which server generates to encrypt or decrypt the data for the secure communication, and this is called server certificates, right? So we have these three kind of certificates: client, root, and server certificates. Now let's look at one of the sample Kubernetes cluster. So we have a master node, we have multiple worker nodes. So when client initiates a request with the kube API server, so this request will go to, let's say, over here. Here will be your kube API server, right? And this request, because this is a client over here and this kube API is nothing but a server for this, right? So this connection also has to be secured, right? This has to be encrypted. So we need certificates over here at the client side and at the server side, right? So we need client certificate over here. We need server certificates over here, both the public and private key pair. Now, the same way, when your Kube API server, or let's say any component of master node, interacts with the worker node over here, let me change the color, and over here, over here. So this communication between master node and the worker nodes, this also has to be encrypted and secure, right? I'm gonna paste it over here, here, and over here, right? So this also has to be encrypted. Now this communication, let's say, is mostly done by API server. So over here, in this case, your API server will become the client, right? Earlier it was server for the outside user or the admin or any other user. But over here, this server becomes the client, right? And these worker nodes, so let's say there is a component to which this API server is interacting with. Let's say it is interacting with kubelet. Okay, in all the nodes or any one of the nodes. So this kubelet will become server over here, right? So let me recap what I have just said so far. So we have a client. Let's say you have an admin, a Kubernetes admin or a DevOps engineer who is trying to interact with Kube API server through kubectl get pods command, right? So for that communication, your user will be the client and Kube API server will be the server. So we need certificate on both the ends. We need public and private certificate over here and over the server end. So here are client and server certificates. And who will issue those certificates? A certificate authority will issue those certificates with the help of a public and private key. Okay. Now, the further communication, let's say Kube API server has to send some instructions to kubelet. So in that communication, your Kube API server will become the client and your kubelet will become the server. So again, we need certificates for Kube API server client and kubelet server. Right? We already had the certificate for Kube API server, so we can use the same certificate for this interaction as well, or we can generate a separate certificate for this one. The same way, let's look into that in more detail. So over here is our user, which is our client, and I've told you that we have generated a certificate, a public certificate, and a private key for the user. Now this user will set up a connection with API server, and I need the lock. Where is the lock? Okay, over here. So this communication has to be secure. So that is why I'm adding this over here. Now a user generated this certificate, which is signed by certificate signing authority. And at the same time, because Kube API server is the server, so a certificate will be generated for that. Now, Kube API server will interact with other servers such as etcd and kubectl. So in this communication, Kube API server will become client and etcd will become server, right? So we need certificates for etcd as well, and we can use the same certificate for Kube API server as the client, or we can generate a new one. Now Kube API server will interact with kubelet as well, and in that case also Kube API server will become the client and kubelet will become the server. So we need the certificate for server as well over here, right? And now Kube API will interact with other components over here, and these are nothing but the clients. So Kube scheduler actually sends a request to Kube API server. Now these all requests has to be secure again. So I'm just gonna add this over here, right? It has to be secure. So Kube scheduler is the client. So client needs a certificate, public and private key, public certificate and private key, and Kube API server will also have the same certificates, right? Like the certificate generated for Kube API server. Now, controller manager is also a client which interacts with Kube API server. So this also has to be secure, and we have to have the public certificate and private key for controller manager. And in the same case, we should have it for the Kube proxy, which interacts with Kube API server over here. Now let's go back. We see over here, there has to be certificate generated for every client, for every server, and root certificates, right? And when we interact between multiple components, like master node interacts with worker nodes, the connection has to be secure and encrypted. That is why we need certificate at both the ends and at the client end. Now over here, we see it in a little more detail. Like when a user is interacting with any component, user is nothing but a client. Let's say the user is interacting through kubectl utility. So let's say the user is interacting via kubectl utility. So kubectl is the client, and we need to generate certificate for user, which is a user certificate. Then we need to generate the certificate for the server, which is a server certificate. And we have multiple client certificates. We have multiple server certificates. And yes, there'll be root certificates for certificate authority. So this is where we need all the certificate. Now, because after this we'll be creating certificates, so I just wanted to explain the concept behind it, and the name of the certificates could be a little confusing as we have different type of certificate, plus there'll be a public certificate and a private key. So let's see how do we differentiate between those two. So we have, let's say, two things. First is a certificate, another is a private key. So anything that has .crt or .pam extension is a public certificate, right? And anything that has key in the name or in the extension. So either it is server.key in the extension or server-key dot any extension. So in this case, it will be a private key. So the easiest way to remember is if you see the word key in the name or in the extension, then that means that's a private key. So you see we have key in either the name over here, server-key, or in the extension .key. So if that is the case, this is a private certificate or a private key. So you remember with the term key. If key is there, that means it's a private key, else it's a public certificate. So public certificates such as server.cert, server.pam, client.cert, client.pam, and so on. So I'm sure this would be a clear distinction now. So if you see the key, that means it's a private, else it's a public certificate. Okay, so now let's go ahead and see how we can raise the certificate signing request and how we can implement this TLS within Kubernetes. All right, so to create a certificate signing request, to approve it, and to look at all the steps, we'll be following the Kubernetes documentation. So go over to the documentation kubernetes.io/docs and then search for certificates. And go over to this link, certificate and certificate signing request, and scroll down to the section where it says create a certificate for the user. This one, how to issue a certificate for the user. Okay, so now we'll be following this document. So I'm gonna keep it on a separate screen so that I can follow along over here in the VS Code. So here's my VS Code. I'm inside day 21 folder where I will be following all the steps. So the first step is to, like, a new user has been joined your team as an admin. So let's take an example. Let's say you are the admin of a Kubernetes cluster and a new user has joined the team as another administrator to share your load. So now you have to provide that user access to your cluster using the certificates. So there'll be different steps involved in that. So first, user will go and create the keys and certificate signing request. So for that, let me just copy the commands and I'm going to keep all the commands over here. Let's create a file, readme.md over here. And this is the first command that I'm going to run. So OpenSSL gen RSA out. So I'm going to create key and a certificate signing request for the user. So consider this a step users are performing. So the user that has joined your team, that user is performing these steps. So OpenSSL gen RSA out and then the key. This is your private key because there is a key in the name. So that means it's a private key. And let's give it a name new admins. Okay. So let's say the username is new admin, or you can give it any name. Let's say Adam. Okay. Adam.key. Okay. And then 2048. Copy this command and run it over here. Okay, now it should create a key adam.key over here. So let's see this. This is a private key, right? So user have this key. Okay. Now close this. And then using this key, okay, generate a new request, a certificate signing request. So open SSL request hyphen new hyphen key, and my username was adam.key out adam.csr. So there'll be a file created using the private key and it will be named as adam.csr subject, and then over here as well you change the user. Okay, so let's copy this and run this command. Now this would have created another file with the name adam.csr, and here is our certificate signing request. So this is a request that we will be processing later on. Okay, so now our request has been completed. Let's go back. Now this is done. Now what user will do, that user Adam will give you access to these things, and he will ask you to create the certificate signing request and approve it on the Kubernetes side. Okay, so as a Kubernetes administrator who has all the permissions, you will create a new file over here. Okay, and I'm gonna name it, let's say csr.yaml. Okay, I'm gonna paste the content over here of this YAML, and API version is certificate. So there is an API provided by Kubernetes certificates.k8s.io. So that's the API that you can use to generate this request, to create the request, and you give it a name over here, Adam, and this is your request. So this should be what you have received from the user. So user will not give you the private key, user will give you the certificate signing request. Okay, so here is the certificate signing request. Now you have to replace it. So let me just delete this one. Okay, and now inside the key, there is a difference. Inside the certificate signing request, adam.csr, the key is in plain text format, but over here in this, we have to write it as encoded, at base 64 encoded. So I'm gonna copy this. So let's, sorry, not this one, CSR. So what I will do, I will cat on this file, cat adam.csr, okay, and then I'll convert into base 64, okay, and this will be the output. But still there is something missing. The key inside the request has to be in one single line, and over here there will be line breaks. So what you can do is to avoid that. So with this command, you can add this syntax tr-d and /n. It has to be base 64, and then there is pipe so that the output should be redirected to the next, and there should be \n. So this is the exact command. And now we have our encoded base 64 key, right? So this is certificate signing request that I'm going to copy, and I will paste that in the csr.yaml file over here in front of request. Okay, now this is the expiration seconds. That means after these many seconds, the certificate will be expired. So usually we keep certificate for a year or so, or you can customize it, and you can remove this line as well if you don't want to do that at this point. So let's just keep it for now. And this looks good. Now what I'm gonna do is I'm gonna apply this file, csr.yaml. Okay, it says the certificate signing request has been created. Now you can do get certificate signing request. You can type the entire thing, or you can write CSR for short, and it will give you the certificate signing request. Now you see over here the status is now pending. Okay, because we have not approved it yet. So a user created the certificate signing request, shared it with you. You as the administrator created this object, a certificate signing request object, but you have not approved it yet. So this certificate sign request has to be approved by an authorized CA, certificate authority, because this is for our internal Kubernetes cluster. We are not using any public CA. We are using the internal CA. Internal CA could be hosted on a server, or by default it is hosted on your master server. How it is hosted? It is nothing but a combination of public certificate and a private key. because we already have our public certificate and private key on the node. So it will use that as the certificate authority. So you can use this server to approve the request. Now, you should have certain permissions to approve the request. The link that I have shared, it has all the details in the beginning, like what kind of role you should have as the administrator to approve the request. But I'm not discussing that now because we have not covered roles, role binding, cluster roles, and all those concepts till now. So that's why I'm not discussing it. But as an administrator, you should have that role to approve or deny the request. Okay. Now we have created the request. Now the next part is to either approve or deny the request. So let's see the certificate signing request. Let's do a describe on it. Describe CSR and then name. Okay. So here is the certificate signing request. And it says it is pending. The name is Adam. And the signer is Kube API server client. And requesting user is Kubernetes admin, and so on. So if you have validated, and if you have validated everything is good, you can approve or deny the request using the command kubectl CSR approve and then the name of the CSR. Okay, so it's not CSR, it's certificate. So kubectl certificate approve Adam. Okay, it says it's approved. So if you do a get CSR now, your certificate is showing as approved and issued. Now, the next part is you have generated the certificate signing request and the certificate is now approved. Now you have to share this with the user. So what you can do get CSR Adam -o YAML. Let's redirect it to a file. Let's call it issued cert.yaml. Okay, and there is this file created. So it has a certificate signing request and few other fields. It is part of the kubeadm cluster admin group, and it is authenticated, and this is the request, and here is the certificate, right? This is not the request, this is the certificate that we have issued for the new user, and it says the CSR was approved by kubectl certificate approve, and it is approved status. Now this is again in encoded format. This is not a plain text format. To give it to the user, we have to decode it. So for that, what we can do is I have copied it. Now you can do echo and then paste everything. Pipe paste 64 and then -d or -- decode to decode it. Right. So if you decode it, here is your certificate, and then you can add this certificate to the kube config, and then you can assign certain roles to it so that user will have certain permissions, and that will be done. The user can access the server using that certificate. So that's how it's done. I'm not showing the next step to add that in kube config and the roles and whatnot because we have not covered that topic yet, but I will explain this once we are there. Okay, so that's all about this video. We have learned a lot. In this video, we have learned SSL, TLS, how it works in general. In the previous video and this video, we have learned how it works in Kubernetes. What are the different type of certificates, different type of keys, public key pair, private key pair, and so on. How do we create the CSR? How do we approve it? How do we approve or deny the request? And how do we share it with the user? So these steps that we have followed now as part of this demo, please make sure you practice this. There will be at least one task in the exam for this, and like you should know as an administrator how do we do that with the help of kubectl, and how do we use this certificate API that we have just used. Okay, so make sure you do that, and there'll be a task in the GitHub repository for day 21 folder. Make sure you complete that in the hands-on. And if you have any issues, have any doubts, you can reach out to us on the YouTube comment or the Discord community, and someone will help you out. And last but not the least, please try to complete the target for this video so that I can keep on producing more content like this, and I can keep on publishing the next videos in the series as soon as the target is completed in the next 24 hours. So please complete that, and please support me in this journey, and try to share this video and the entire series with your friends and colleagues so that they can also learn Kubernetes while you are doing it. Okay, so thank you so much for watching, and I wish you have a good day, happy learning, and I will see you soon.